This I will solve third one also, and fourth one you have to do for a homework. Third example, before writing mentioning the given data, I have read it first. A thermally isolated pot has 150 gram of ice at a temperature of 0 degrees Celsius. 150 gram of ice, that is M1. Okay, ice of its mass is 150 gram. Ice is a mass of 150 gram. Okay, they have given that M1. Okay, you have to write down mass of ice M1 is equal to 150 gram. Okay, 150 gram. Okay, after that what happens? How much steam of 100 degrees Celsius has to be mixed to it so that water temperature becomes 50 degrees Celsius will be obtained. So that we have to find out the mass of steam, that M2. Okay, M1 is mass of ice, and the conversion of this ice cube or a slab into water. Okay, how much steam of 100 degrees Celsius to be mixed to so that the water of a temperature 50 degrees Celsius will be obtained. Conversion of a ice, that slab of ice, into water, but water of a what temperature? 50 degrees Celsius. 50 degree Celsius. So that delta T is here. 15 minus 0, that is 50 degrees Celsius. 50 degrees Celsius. There is change. Ice having the initial temperature 0, and it is converted into water. Conversion of ice into water, and water having the temperature 50 degrees Celsius. So delta T, the change in temperature, is 50 degrees Celsius. After that they have given a specific heat of water. Okay, specific heat of water is 1. That is 1 calorie per gram degree Celsius. That is serious unit, because already it is in gram, and so we have to instead of 1 kilocalorie per kg degree Celsius, we have to write down 1 calorie per gram degree Celsius. Okay. After that they have given the latent heat. They have given latent heat of ice, that is L1, that is 80 calorie. 80 calorie per gram. 80 calorie per gram. And also they have provided that L2 is vaporization of water. Latent heat of vaporization. Latent heat of vaporization. That is L2. That is 540 calorie per gram. 540 calorie per gram. Okay. So delta T2 is also given that, and delta T2 is 100 minus 50. 100 minus 15, because the initial temperature of a steam is 100 degrees Celsius and it is converted to 50 degrees Celsius of water. Okay, 0 to 15 is one step, that is one transition, delta T. Ice to water of a 50 degrees Celsius means 15 minus 0 is equal to 50 degrees Celsius, and steam to water. We have to mix a steam. With a ice. So there is a condensation is taking place, and it is converted into water, and this water having the temperature of a 50 degrees Celsius. So delta T2 is 15 minus 100 minus 15, that is 50 degrees Celsius. Okay, the examples are too difficult to understand. We have to read it first, read the theory regarding with it. After that we have to solve these examples. Okay, and specific heat of they have been also, and we have to find out the M2. M2 is mass of steam. Okay, they have been asked the mass of steam. Okay, I think you know about those. I just explain those things. There is an isolated pot is there. In isolated pot they have keep the ice of a 150 gram. We know that the temperature of ice is 0 degrees Celsius, initial temperature. Okay, and what we have to do, we have to convert it into, and we have to mix a steam of 100 degrees Celsius. So initial temperature of steam is 100 degrees Celsius. So ice and steam mix with each other, and we have to obtain a water of a 50 degrees Celsius temperature. Here is ice of a 0 degrees Celsius. Here is a steam of 100 degrees Celsius, and we mixing these quantities. Ice of a 150 gram and steam of how much quantity of gram, that we have to find out. And mixing these two quantities of a different temperature. It is 0 degrees Celsius, that is ice, and the steam is 100 degrees Celsius. And mixing this thing, how much amount of steam is needed? To convert this water? The condensation is taking place in presence of ice. So there is condensation is taking place. Condensation of a steam, water vapor. Okay, and it convert into water. And this water having the temperature 50 degrees Celsius. So what you have to do? Heat absorbed by the ice first. Heat absorbed by the ice. Heat absorbed by ice, that is Q1. First ice is converted into water. After water is converted into some sort of heat provided, after that it gains after taking heat energy, its temperature rises to a 50 degrees Celsius. So that there are two phases are there. So first one is heat absorbed by the ice, that is Q1, and that is equal to M1 L1, that is M1 L1, and M1 L1 is equal to, M1 is a mass 150 into L1 is 80. That is the latent heat of ice, and its total value is 12,000 calorie. It is not a kilocalorie because we have converted it into kilogram to gram. Okay, so first one, Q1 is the heat absorbed by the ice to convert it into water. After transformation of ice into water, we have to raise the temperature up to 50 degrees Celsius. Heat absorbed by water formed by melting. Heat absorbed by water, which is melted. Means melted water. Melting of ice into water, and this water gains once again in heat energy, and its temperature rises to 50 degrees Celsius, and its value is MCT, that is M1 CW delta T1. M1 is the mass, that is mass remains same, that is 150 into into specific heat of water 1 gram 1 calorie, specific heat of water 1 calorie per gram degree Celsius into delta T, temperature, that is delta T1, okay, delta T1, and its value is 50, so that Q, and its total value is Q2. Here we have to consider in evaporated one Q2, and Q2 is equal to 75 calorie. That is 7500 calorie. Okay. So these are the two things. Afterwards, what happened? Heat given out by a steam. Heat given out by steam. There is a transformation is taking place. There is a transformation of a gaseous state into a liquid state. So heat is given out, and this is Q3, and this is M2L2. M2 we don't know. We have to find out the mass of steam, and L2 here is 540. 540 gram calorie per gram degree Celsius. Okay, this is third one. This is Q3, and last one, that is Q4. So heat given out by water formed on condensation. Heat given out by water formed by condensation, and that is Q4, and it is M2 C2 delta T2, M2 C2 delta T2. C2 here is the same thing, W, okay, and its value is by putting values we have got M2 you have to find out, okay, M2 into 1 specific heat of water, and delta T2 is 100 minus 50, that is also 15. Okay, here is Q4. Okay, here is Q1, here is Q2, here is Q3, and here is Q4. Okay, but according to the principle of heat exchange, but according to principle of heat exchange, Q1 plus Q2 is equal to Q3 plus Q4. Okay, so we have to put the values. Okay, Q1 plus Q2 is equal to Q3 plus Q4. So we have to add these values, and adding values, Q1 is 1200 12,000 plus Q3 is equal to 7,500 is equal to Q3 is equal to Q3 is equal to M2 into 540 plus Q4 here M2 into 50. Okay. Okay, okay. So after that, what happens? Its value becomes 19,500 is equal to M2. You have to take common 540 plus 50. Okay, that is M2 into 590. Okay, so M2 is equal to upon 590. So 19,500 upon 590 gram, and its value becomes, after calculating, we got it as a 33.05 gram. 33.05 gram, and that is 33.05 gram of steam is mixed with ice. So have you got this thing? So it needed 33.05, that means almost 33 gram of a steam, okay, water vapor, that is steam is needed to add with 150 gram of ice, so that we can form the water, condensed water, and which having the temperature of a 50 degrees Celsius, that is of a 50 degrees Celsius. So that here is M2, here is M2 of a 33.05 degrees Celsius. I have already mentioned you in this lesson the numericals, that means the problems related with the topic heat is quite difficult to understand. There is so lengthy things are, we have to write down those things, and we have to understand the transition states, what is meant by latent heat is there, specific heat, and something, the mass of every object, and this thing you have to understand in that problems when we solve this thing. I think it would be asked in our examination that higher order text hot questions of a 3 marks, not a 4 marks, but 3 marks. It can be asked. So I just stop here. The fourth example of a calorimeter, you have to solve in your this. I just give this example to solve you for a homework. If you not understand this example, I will solve here, but for solving this example you have to mention this thing, you have to write down in a comment box in that particular lesson below. You have to comment it, sir, I don't understand this example, you have to please solve this and use your tactics to solve this thing. Okay, so I just stop here.